Is Corey here? Hi, Corey. Hi, finally you joined here. Yeah, thank you.
Thank you. Thank you for having me.
Thank you for your time to share to us today. And yeah, yeah. I think we should wait for a few minutes for
Sure,
some
no
people to
problem.
join in.
I'll just try to get myself set up.
All right. Okay.
Let's see. Let's present. And you see that all right?
Yeah.
All right, good.
So I think probably we should start right now because I was waiting for people who asked for requesting to join in, but still not getting any. So I'll read some a bit of your profile here. So Corey is principal engineer from OVO, and he will present how to fix tightly coupled Go code. So as you can see, the description on the page Meetup. So Corey, please you can start the presentation now. Thank you so much.
Okay, thank you. And couple of sort of housekeeping things before I get too far. If I get too excited and talk too fast, please jump in and tell me to slow down. Beyond that, if you have a question, by all means, either shout it at me or send it via that link that I just posted in the chat. I'm very happy to stop and deal with things rather than coming back. Other than that, yeah, let's make a start. So today's presentation, as you can see, how to fix tightly coupled Go code. This is something that, frankly, I didn't really think was a big deal when I started writing Go. And I've come to believe that it's actually quite important and the basis of many problems and sort of the solution that I'll present to you today is kind of informs a lot of how I structure my code and structure my apps. And yeah, anyway, let's just jump right in. So a little bit, see, I'm on the right page. There we go. Okay. A little bit about me. I had many technical jobs over the years, including technical management and coding, but recently principal engineer at Grab and now at OVO. And through all the jobs that I've had, I would have to say that coding has always been my sort of most desired activity. It's the one that gives me the most fulfillment, I guess. Not just writing code, but reviewing code and debating code with people of all levels and all backgrounds. I find that
Again, this is
a
the
good
problem.
debate helps us learn.
In most
And that's
of our
why, as I
textbooks,
said
when
to
we
you about
discuss
questions,
professions,
jump in and
we talk
contradict
about
me
doctors,
or
we
ask
talk
for more
about
clarification.
engineers,
That's all good.
we talk about all these
Today,
high-tech
as I
professions.
mentioned,
But
this
there are also the other professions in
topic
this
is
world which are
something that
equally
is
important.
was a lot of my
What are the
mistakes
jobs that are
that I
not
want to share with
usually
you and
mentioned
how
in our textbooks?
I identify and
So,
avoid
again,
these problems now
participant teachers, I request you
in my day-to-day. Okay,
take
so
2 or
firstly, tightly coupled
3,
code.
think
Why
about the
does it even
topic
matter, right?
and try and
Have you
enter your
ever
answers. What are
added a
some of the
feature to a
jobs that
project?
are not usually mentioned
Sorry,
in the
1 second.
textbooks, which you think are also very important for the
I'm
society?
busy, buddy. Please. Sorry,
Every member
I'm
of the
schooling.
society is important, right? That
Okay, sorry, back. Yes, have you ever added a feature only to have another feature break? Have you ever fixed a bug only to cause another bug? You know, have you ever spent hours trying to figure out a problem only to find the problem in some completely unrelated code? These are all symptoms of coupling or overcoupling. Okay, so what is coupling? Coupling is the measure of how much two objects, two functions, two structs, two packages depend on each other. If we're going to put this a different way, it's a measure of how likely it is if you change one object, will that influence or force a change to another object? Now, when we talk about loosening coupling between two objects, we are essentially trying to make these objects more independent of each other so that they can be used, extended, and evolve completely independent of each other. So jumping in with an example. As you can see here, we have two structs, a person loader and a person loader config. These two objects can be considered tightly coupled. They are tightly coupled because the person loader class, excuse me, if I keep saying class, struct, same thing, interchangeable. The person loader class cannot exist without the person loader config class. Now, this may not seem like there's anything wrong with this relationship, and in fact, you might find this in your code quite often, but this relationship can be improved. Now, when we set out to improve this relationship, we should be asking ourselves questions like, where is this config coming from? Often, config like this will come from a JSON file, right? Where's that JSON file being loaded? Where is it being parsed, and where in the rest of the application is it being provided to this person loader? Most likely, the config is being loaded in another place, in another package. Let's see how this plays out. If we introduce a config package and make it responsible for loading our JSON file and providing it to our person loader. We have a nice decoupling of concerns, or separation of concerns, if you like, between the loading and loading of the config. But we've actually introduced a problem. As you can see on the right-hand side, our config package depends on the person loader config. The person loader config, the person loader, on the other hand, is also going to depend on the config package. So we've actually created a circular dependency, which in Go, as you well know, is not allowed. Now, we could introduce a third package and have that package responsible for calling the config package and then providing the person loader config to the person loader. But that's the start of a mess. And that mess is something, obviously, we want to avoid in the long term. Okay. Forgive me, I'm going to go sideways a little bit and talk about dependency inversion principle. Now, dependency inversion principle is one of the solid principles, as introduced by Uncle Bob, or Robert C. Martin, if you like. Dependency, and all of the solid principles pretty much seem very wise when you read them. But if you're anything like me, very hard to understand or very hard to apply in your day-to-day. I know personally I spent a lot of years like, okay, they're there, I know of them, I try to refer to them. It wasn't actually until much later that I was able to see their significance and then how to apply them to Go. So, dependency inversion principle specifically. Dependency inversion principle states that high-level modules should not depend on low-level modules. Both high and low-level modules should depend on abstractions. Similarly, it goes on to say, abstractions should not depend on details. Details should depend on abstractions. Now, if you're anything like me, that all sounds clever and wise, and it is, but it's pretty hard to understand. And so let's break it down and convert it into Go, a bit more Go language. Firstly, high-level packages should not depend on low-level packages. So let's look at what high-level packages and low-level packages actually mean in Go. Here you'll see a fairly typical structure in a Go application. You're going to have a main package, which then includes the API package, which then calls a business logic package, which then calls the storage package. Now, to expand on these a little bit, they're kind of the MVC. So API would be where your HTTP stuff is. The business logic, obviously fairly standard, doing the validation and things like that. And then storage, package that's interacting with the database, right? It's, like I said, fairly typical web or REST service structure, right? In this structure, the high-level packages can be easiest thought of as the packages that the main package is calling. Now, obviously, it's not a strict or hard and fast rule, but it's the top level of the structure, if you will. The low-level packages are therefore anything below that, anything being called by API or even lower as you go down. Okay, so Uncle Bob's point here is that the high-level packages shouldn't depend on the low-level packages, and the low-level package shouldn't depend on the high-level packages, but instead they both should depend on abstractions. And we'll dig more into this as we go. Digging a bit more into this, you see now our business level package is calling the MySQL package inside the storage package. So, excuse me, MySQL struct inside the storage package, right? But if you think about, if you ask yourself the question, does the order manager in this structure actually need to know where the data is stored? And the answer is not really. The business logic here needs to know where it can get the data or who can ask get the data from, but it doesn't need to depend on implementation details like the fact that it's MySQL. And this is probably something you do automatically without thinking about exactly why. This is why. Now, second part, abstraction should not depend on details. Details should not depend on abstractions. Now, if we translate this into Go, we can then say instead, interfaces should not depend on structs. Structs should not depend on interfaces. Now, that pattern actually sounds familiar to another common proverb, which says, accept interfaces and return structs. Now, you may think the most extreme or the most perhaps correct interpretation of this statement would be interfaces should not depend on structs, and structs should not, excuse me, lost. Interfaces should not depend on structs, and structs should not depend on interfaces. Okay. You may then think that the logical extension of this principle is that we should be accepting interfaces always and also returning interfaces always. But in actual fact, while that is strictly what Uncle Bob is saying here, it's not necessary because of Go's implicit support for implicit interfaces, which we will see a little bit more as we go along. Okay, breaking down a little bit further, struct should not depend on structs. As you can see, we have a pizza maker struct, I should say, and our make pizza function is accepting a struct as an input. Now, because of this relationship, the pizza maker and my super pizza oven 5000 are tightly coupled. In actual fact, they don't need to be tightly coupled because the pizza maker doesn't care or shouldn't care what kind of oven it's using to bake the pizza, as long as it's able, an oven that's able to bake. So we can separate and decouple these two objects very simply by introducing an interface which defines the requirements. So instead of being specific like we were in the previous slide about we need this very specific oven, we now flip the relationship over and say we need an oven, something in this case that performs the bake method, but we don't care what it actually is. And thereby decoupling these two, or this pizza maker from any oven, which we actually then can use. The second part, interfaces should not depend on structs. As you can, if we revisit our earlier example of person loader and the config, and this time flip it over and so that our person loader is not a struct, but an interface, you can see that by accepting a struct as a parameter, we are still tightly coupled to that struct. Now, this means that, similar to the previous point, any place where we want to use this interface has to depend on this struct. And like this could be in a lot, this will lead to a lot of dependence on that struct, and likely a lot of cases where we are forced to create a new config object to call this method. This constant churn, if you will, of creating and garbage collecting these objects can actually result in a lot of unnecessary object creation, can result in a lot of object creation and destruction, which then wastes your CPU. It's better if we get rid of that struct entirely and replace it with an interface. Now we have the ability to potentially reuse the config and avoid that object creation and destruction cycle. We also allow users of this interface to completely decouple from the person loader struct in the first place. And they can provide, of course, then provide whatever implementation they deem necessary. Okay. Now we sort of looked at what coupling is and the dependency inversion principle as a more academic perspective on coupling. We can look at fixing tightly coupled code. So, introducing another example. As you can see, we have two packages. We have a people package and a shoes package, or person struct and a blue shoes struct. Our person, so the thing that we should note here, firstly, they're tightly coupled. Quite obviously, it's the start of the example. The person is tightly coupled with blue shoes because it relies on, as member data, an instance of the blue shoes. The person, second thing to notice, the person only uses the walk method, yet the blue shoes has a walk and a run, and we will come back to why I've highlighted that specifically, but just keep that in mind. And the third thing is perhaps more logically, at the moment, the user can't change their shoes. Now, if you're like me and have a Java or a C++ type background, your first instinct was probably to think, okay, I'll introduce an interface. Introduce an interface. The method by which we introduce the interface would be to look at the methods that are on blue shoes and basically retype them as an interface. So we've now introduced a footwear interface, which has the same methods as the blue shoes and is in the same package as the shoes package. Now, in a lot of languages, C++, Java, for example, you would put implements footwear on the blue shoes and you'd be done. However, Go has this support for implicit interfaces that I mentioned earlier. We can actually use this support for implicit interfaces to decouple these packages and these objects even further. Now, before we jump down into that, we should fix that last problem I highlighted to you. The fact that the person struct it depends only on the walk method and not the run method. And you'll see that our footwear interface has two methods, one of which we don't use. Now, if you are familiar with the solid principles that I referred to earlier, there's another one, the ISP or interface segregation principle, which states that clients should not be forced to depend on methods they don't use. Now, I believe the goal here of Uncle Bob and this principle is to be very specific about the relationship between two objects. Now, when we use the interface to document a relationship between two objects, which is essentially what an interface will do, by reducing that interface to the minimum possible interface, then it's not just specific and concise. As a consequence, it's also the documentation of that relationship is very easy to understand and very easy to maintain. If we then, instead of having the footwear interface in the shoes package, move it over to the people package, we have resolved our coupling, but we've also resolved all our other issues as well. So what you'll see here is we've now reduced our footwear interface to just the walk method, and the connection between the people package and the shoes package is completely incidental. If you use the people package, or if you are maintaining the people package, you have no relationship or no required relationship with the shoes package. We've actually flipped over the relationship. Traditionally in Java and C++, the interface is, this is what I provide. This is what the interface is documenting, if you will. It's a statement of, these are the functions, these are the features that I provide as an interface. In this case, it's not provide, it's require. So by moving the interface to the people package, we are now allowing the person class to say, this is the features that I need, which is not just more specific and, as we've said, decoupled, but it also becomes documentation, which, if you're anything like me, it's free documentation. It's stuff that I don't have to type. And I know you're probably looking at this thinking, it's a small matter. What does it matter where the interfaces are? I would share with you a minor aside and say that there was a job I had where the build tool was first calculating the dependency tree and then building every package that was depended on. Now, as a consequence of the fact that we weren't using this style, we were instead using the more Java C style, we ended up building the entire universe quite frequently, especially if you were making a change to a package that was then used by someone who's, down, I provide this to you, you provide that to them, and all of a sudden you're rebuilding the entire universe. And that makes for unhappy developers, because your builds take too long, they become unstable and just problematic. If, on the other hand, you flip the relationship over and talk about, this is what I need, that coupling is not there. It may be there in tests, so you don't have to worry about accidentally changing things and breaking other people, but it's not there when you're calculating the build path, if you will. Okay, a couple of questions. Yep. Okay, this question, what is the best practice model in Golang? Could you expand on that? And Ronaldo, did you get the link to the slides? It should be in the chat. I'll just repost it in case Google hasn't shown up. Okay. Let's look at a sort of reverse or inverse example. Okay. Let's say you're building a REST API. This time it's a get user API. Okay, so hopefully pretty normal, pretty standard. You would likely end up with the same sort of three packages that we talked about before, an API package, a business package, and a storage package. Again, sort of very similar to the MVC. Hopefully not anything too crazy. All right, so we dive a bit deeper into this. We start at the bottom. Let's assume inside our storage package, we have a struct called user store, which is taking care of loading the data from the database for us, right? So it's not hard to guesstimate that it has a method called load by ID, which returns a user and an error. Okay, and you can see the user struct that we have there, which is simply a data transfer object or DTO, which would likely mirror the contents of the database pretty closely. Okay, moving up next level, excuse me, the business logic layer. So in the business logic layer, we might have a class struct called user loader, which predictably uses the store that we had. It itself has a load user method, which probably does some validation, authentication, logging, access control, any of this sort of stuff, the business logic, and then calls to the storage layer to load the data and then returns it back up to the API layer. Okay, moving on to the HTTP handler. HTTP handler, as you can guess, deals with the HTTP. So it passes the form, it extracts the user ID from the request, and then dispatches the request to the business logic layer, and then takes the response from the business logic layer, wraps it in JSON, and sends it over the wire. All looks good, right? There's a problem. Let's see if we can find it. So one day, a user request comes in, another request, the fellow says, I'd like you to add a login feature so people can log in and maintain their own details. So you're like, great, start working on the feature. One of the first things you're likely to do is start a database and add a password field, as you can see on the right-hand side. We add a password field to our database, and then add it to our user struct, and then implement the rest of the feature. All's going great. We release the feature, and bang, we just leaked everybody's password. This was the problem I was alluding to before. Now, the problem here can be looked at in a couple of different ways. Firstly, we've coupled the user struct to the data model. Now, that coupling is perhaps a good example of the fact that it's not bad coupling, like not all coupling is bad. The fact that this DTO maps to the database, it's pretty standard. I mean, what else would it be? Okay? Not all coupling is evil. We could argue that the business logic and the API layer are both coupled to the storage package user struct, because this user struct has been passed up through the layers from the storage to the business to the API. And that's how the password got leaked, because it was automatically JSONified and sent over the wire because of an unrelated change, right? We could address this by creating objects at each layer. So having the user layer having the storage layer return a storage user object, having the business logic layer return a business logic level object, and then having the API layer have its own object. But as I mentioned before, you end up then with a lot of churn, a lot of creating and destroying of objects, which are just wasting CPU cycle. We could take a more traditional approach, traditional being a C++ or Java type approach, and define interfaces and return interfaces instead of structs. But frankly, you'd end up then with a lot of interfaces at every level, and it would start to violate Go style, for want of a better word. I mean, Go doesn't really do getters and setters. And even just beyond that, you end up with a lot of duplication, which sometimes duplication is necessary, but in this case, there's another way. What I would propose to you is we look at the problem slightly different way, right? If instead of directly JSONifying the output, we only create a new object at the API layer, we leave the coupling between the storage and the business logic and even the API layer, so that object gets passed all the way through, which means we don't have the cost of creating and destroying objects, right? But at the very, very last level, we define a special struct which maps our expected output. And we populate that struct from the other one. Now, this might sound like I'm contradicting myself a little bit because I'm intentionally creating an object for the sole purpose of just generating the JSON. But I think in this case, the cost is worth it because this struct cannot change accidentally. So we cannot accidentally leak data that we didn't intend. We cannot accidentally regress our API by, say, removing a field without the thing failing to compile, for example. And yeah, if there are any other things like having to change formats or change names, we're not having to affect the rest of the code. For example, let's say the ID that the API contract says has the email, written backwards for some other reason. you don't have to change the way the email is stored the entire way through the project just to have a very specific user output that you're looking for. Okay, so I will quickly admit, this is my first thank you page. I have another, but let me just sort of stop and say, how are we doing for time? Are there questions? Is there anything you guys want me to deal with sort of now? Otherwise, I have a little bit of extra content we can get into. Okay, so how should we deal with these questions? Ian says, what do you think when a third-party hard dependency, like GORM or MUX, Gorilla MUX, are scattered all over the service and imported in lots of places? So that's a good question. To be blunt about it, I make a point to stop it. Like I really introduce the sort of hard boundaries on these layers. I don't know if you're familiar with either Uncle Bob's talks on adapter layers or some of the other things that on the internet. You'll find something called the onion layering system. Basically, the structure that I'm showing you here is essentially the onion layer. So the API knows about the business and the business knows about the storage, but the relationship never goes the other way. And that's actually how the dependency inversion principle got its name, because dependencies go the opposite way to what you think. So to specifically, yes, I use Gorilla MUX. I would stop it very hard at the API layer and make sure that's the only layer that imports Gorilla. So I will turn my request into a DTO. I will pull the MUX variables, put them probably also in that DTO. And then the only thing I'm putting down into the business logic layer is pure Go. No, excuse me, pure DTOs, not no more Gorilla after that. Regarding the last example, does it mean the user load struct will be visible to the package only? If so, how to make the user data being used outside the package? This last example, this one, Akram? The user, yeah, so the load user response is private, and that's on purpose. I subscribe to the theory that you should make absolutely everything private until you're forced to do otherwise, just as a sort of a self-protection mechanism. You know, like the more you make public, the more you have to support potentially, whether you mean for it to be public or not. So that's why it's private. That's my instinct. But the JSON marshaller and unmarshaller only need the fields themselves to be public. The struct itself doesn't need to be. So this struct won't be used outside the API package, except to obviously pass to the JSON. So Jawed says, any book you know listing going deep into this principle. So in these slides, I have linked to Uncle Bob's website where he goes into the solid principles. I find his website's often down. I'm not sure why he hasn't bothered to have a better one. But it is there, and that is the original content. If you allow me to self-promote for 5 seconds, I have written a book on dependency injection, which I have a whole chapter on the solid principles, and I go through what I think they mean to Go. So obviously there's that. As to other books, I think there is one more, and I'm afraid I can't remember. A lot of people look at the solid principles and go, oh, it's OO, Go isn't OO, therefore, you know, it's not for Go. And I strongly disagree with that. I think they are, in the abstract, very general principles with very good reasons. They may not directly correlate. Like you might have to squint a little bit and see when it says struct, you say class and things like that. But they do definitely apply. Ivan says, is your share telling about one of the solid principles? What I know is solid is tackling tightly coupled code. Is there other principles that we should read beside solid principles? Yeah, so like I said, the solid principles are all great. They're very hard to understand. So you've got to, I think, read them and then put them away and then read them again 6 months later to see sort of what it means. I've been reading them on and off for, I don't know, 20 years or whatever it's been, and I'm still not sure I've got them all. If I was to recommend something very specific beyond solid principles, I'd say absolutely go and get the Clean Code book by Uncle Bob, because it's frankly life-changing. It talks a lot about the soft stuff. You know, our day-to-day is always about making features and making it work and writing tests, and it's very churn business related. When the quality stuff tends to drop off, the Clean Code book, it very specifically goes through, you know, this is what clean code looks like. This is how variables should be named. We should look at things like having functions that only have a few arguments, because the more arguments they have, the more confusing they are, and a bunch of that sort of stuff, which I think everybody I've ever spoken to that's read that book is sort of blown away by it. Beyond that, I always recommend anything Kent Beck writes. And I don't know, that sounds grandiose, but that guy's possibly the smartest guy I've ever seen in terms of software. He's not always easy to follow, but when he says something, it's generally pretty spot on. No, I'm sorry, I cannot pronounce your name. The question is, what do you think about interface pollution? How would you consider to use a real struct instead of an interface? So by interface pollution, I'm guessing you mean fat interfaces, interfaces with lots of methods. Short answer is, when you look at the ISP principle, which basically says you shouldn't depend on anything you don't need, you end up with a lot of very small interfaces. And I believe that fits with Go style, meaning that Go style is, from my mind, everything about being simple. It's very much the Unix principle of do one thing, do it simply and do it well, but then make sure you can communicate with others. So that's why you always see in Go interfaces like the JSON marshaller or unmarshaller, they are singular functions. Now you often implement multiple ones. It sounds a bit weird to have an interface for marshal and an interface for unmarshal, and similarly in the database, there's an interface to convert a custom value to a database format or from a database format, but they are very specifically and very intentionally split to avoid this pollution, and to basically allow you to adopt only what you want. You know, if you have no need of the reverse, then you don't have to implement the reverse. Okay, what else have we got? What is libraries patching for unit testing? So hopefully you're not talking about monkey patching. And if you have a look at my website, there is a very old article about dependency injection and monkey patching. Similarly, there is a chapter in my book on it, which I hopefully wrap up by saying, don't do it. One of the big sort of messes I made in Grab was to introduce monkey patching in Go, which is essentially, for those who are not familiar, where you can actually define a function as a variable, which then allows you to easily switch out that function for another function during testing. The problem is, similarly to the problem with testing with globals, is you then have a single instance and you have multiple tests trying to access and replace that function or that global. And then means you are forced to either write your tests single threaded, which is just a recipe to waste time, or run them multi-threaded, and then maybe they're not reliable. As far as libraries, I can't shake my Java roots. I use the Testify library, which has a lot of assertions. I like to use assert dot or require dot. I find it more concise than the Go standard, which is odd because just about everything in Go is about being concise and simple. So normally the mistake is to introduce a framework or more code to match a previous language pattern, but actually makes it worse. But that's a soapbox I shouldn't get on. What is the difference of which one is the detail, which one is the abstraction? How do I know that the file contain an abstraction or the file is detail? So I don't know if it's good or bad, but in my Go files, I don't make specific files for, one file for an interface, one file for a struct, as you might do in Java. I do, however, have patterns. In this case, as I said, I'm defining interfaces where I use them. So I will typically have, globals at the top, constants, any kind of variables, private ones, preferably like errors, then constructor, then the type, then the methods. And interspaced beyond that, the functions and the dependent interfaces. So for example, we looked at using config as an interface instead of a struct. I would typically have the struct that uses it and then the config underneath. It might seem weird because in a lot of cases you need to know what the config is before you can use the object. But at the same time, once you know what the config is and you have called the constructor or constructed that config object, you don't need it anymore, which is why I have it at the bottom. But that's a personal style, it's not a requirement. Good question. What's the sign of over abstraction? Yeah, I've seen people get on that soapbox. I like, as I sort of said, I like to have my layers very separate, but I'm realistic, so if you have a look at my API code is calling the business logic code. Now, that business logic code may or may not be injected depending on what else is going on. I'm not sort of overly stringent about it. If I don't need to swap something out, okay, let me put it this way. If I don't need to swap something out, then I won't. And if I don't need to swap it out for any other purpose than testing, then I won't. And let me just sort of jump ahead. In these slides, and by all means, please go through them, I look at dependency injection, and we're running out of time, but the very short version is this is what happens when you try to do dependency injection the first time. It's not over abstracted, but it's over injected. And from the clean code book, it says, three parameters is a good max. Less is even better. So I took this and said, okay, the first thing I can do is get rid of the things that are standard, aka the logger and the stats, and then introduce this idea of config injection, where you just smash them together so that you can forget about them, which also helps because these things are going to come from a central place, like the main or the application config, something like that. So you'll find you copy paste and then you just forget because you know where the config and the stats always are, and they're always in the same place. The second thing I look at is in this handler, I have an authenticator, which is actually an implementation detail, which what I mean by that is the authenticator doesn't get swapped out for any reason except testing. And obviously, I'm swapping out during testing to test, to make the rest of the code testable to auth failures or to not have to call the auth system or whatever it happens to be. And I then instead change my public constructor so that that is just not injected. And this is a new style I've been working on for the last couple of weeks, where I've introduced a second private constructor and left the injection there. Now that sounds weird, but what ends up happening is constructors often do more than just populate a struct. You know, they might create a map, they might create some Go routines, they could do, frankly, a lot of things. Now, they shouldn't do too much more than creation, but even just creation, like maps and channels, is already going to get you in trouble. So if you were going to create the struct manually in your tests, you'd end up with these big chunks of initialization code, which could be easily just replaced with a call to a private constructor. And forgive me, I know I got a little bit off track there, but this to me is over abstraction or the sort of consequence of or test-induced damage, perhaps, that comes from too much dependency injection.
Yeah. So Corey, if I may interrupt.
By all means.
Yeah. We are getting closer to 2 p.m. So still, how many questions do you need to answer? Or maybe only one left question for you to answer.
You tell me.
Okay. So I think one more question to answer. Is that fine?
All right. Cool. Okay. So
yeah.
So the question is, where do you think the best place to decide what hard or specific dependencies to use and to load all the configurations? Is it the main, etc.? So yeah, that's a great question too. So I hate to give you the answer, but the answer is it depends. I will typically make myself a config package and have, like I said, the JSON there. I also have my config and my stats and anything standard there as well. So it's easily handled through this config injection that I was showing you. I will typically have in main then the calls to the significant object creations, typically the top level modules. I try to avoid the massive wiring up of things if possible. Look for, like I've said here in this slide, other ways of paying down the cost. But yes, main is the answer, the short version. But you want to pay that cost down because unless you want to use a DI tool package, which there are, it just becomes a bit of a nightmare. All right. I'm going to wrap up my part by saying thank you again. This is where I'm at. If you need to ping me about any of this or anything else for that matter, email, Twitter, or my website, feel free to. All questions, comments, or abuse.
Yeah, so people, if you want to reach out to Corey, please reach out to those links. They got Twitter, right? And then email. Yeah, so thank you so much once again, Corey, for your time, for the presentation today to us. Or maybe in future, I will reach you out again to be the speaker again here in GoJakarta.
Sure.
if that will
Thank
be
you.
fine.
Thanks for having me.
Thank you, guys. Thank you,
Okay.
Corey. Have a great
Thank you,
day.
Corey.
Thank you. Thank you.